Hey Mr. Suhu, it's Andrea, and this is my Unit 9 video, so I hope you can get through it without falling asleep. Okay, so this is going to be about trig functions, and the trig functions we use are sine, cosine, tangent, and cosecant, secant, and cotangent. So first we're going to be placed with a right triangle, which is right here. And to find the sides, we're going to use the Pythagorean theorem. So these two sides are given to us, and we're missing this side. So we have side B, and we have side C. So you plug it into the Pythagorean theorem right here, and you get the next leg, and that's what it's going to be. And this is beta right here, just for people that didn't know. So then you plug them in for sine. Sine is opposite over hypotenuse. And sine, cosine, and tangent have these cousins, and these are their cousins, and basically the cousins are opposite of what they are. So like adjacent over hypotenuse is cosine, and secant, which is cousin, is hypotenuse over adjacent. Now you see that it's 8 over 2 square root 7. It can't be like that. It could be like that, but square roots cannot be at the bottom on a fraction. So you multiply it by square root 7 on each side, and you get your new one. Same thing we did right here. That's a no-no. That's a yes. So yes, we used the Asian method that Mr. Suhu taught us to memorize the cousins, which is basically memorize it. Or you could use SOHCAHTOA, which would be fine too. But yeah, so these are trig functions. So now we're on to the next thing, which is the unit circle, and I kind of had to improvise here. So I know it looks scary, it's all kinds of numbers and stuff, but it's honestly not that hard to understand. So there's a pattern with the degrees. These are the degrees all right here, and it makes it until 360. So basically the pattern is 30, 15, 15, 30. Like right here, 60 plus 30. And then 90 plus 30 is 120. 120 plus 15 is 135. Add another 15, 150. And then add 30 again is 180. And that's the whole pattern around this. And also find all the radians. The radians are all right here around the entire circle. To find the radians, you just divide 30. Like for example, there's angle 30. You divide the angle by 180 because half of the circle is in fact 180. So you just do that with each of them, and then you get all of the radians that you need. Okay, so for the degrees, it's fairly easy. It's a trick, but so basically the hypotenuse for the unit circle is going to be 1. So for the first one, this is a 30-degree angle. So this triangle is going to be 30, 30, 60, 90. So the hypotenuse is 1, and then you use the 30, 60, 90 triangle rule, and you get square root 3 over 2 over 1/2, and then you get square root 3 over 2, and then 1 over 2. And they're basically all the same around the triangle, except just in different orders and with negative and positives. You could basically look at this as a graph. It's just split like this, and there's 4 quadrants. So this is going to be positive, this is going to be positive, negative, positive, negative, positive, negative. All of these ones are going to be positive, and all of these ones are going to be the y column is going to be all negative, as you can see here. And then, okay, so the next thing we're going to do is graph a sine and a cosine graph. So the first one we're giving is 3 sine x. So for this one, in order to graph it, the y value is the sine value. So you bring back the unit circle. Your first point is 0. You start off at 0. And you go here, and this is 0 right here on the radian. And since it says the y value is the sine value, it's 0 right here. So you are plotting it right there. The next one is pi over 2. You go back to the unit circle, pi over 2, and it's going to be 1. So you plot 1. And you do the same things for the given ones that are right here. And that gives you your parent line. Then the next thing you got to do is you have to graph the translation. In order to do that, you have to multiply all the y values by 3. So for example, 0 times 3 is 3, so it's going to stay there. And then pi over 2, the y value was 1. You multiply that by 3. Your so when you go back to the amplitude is 3, and also the amplitude always is the number in front of sine, and which is 3. So that's your parent graph, and this is the translation. It's in a vertical stretch because the graph is stretching, as you can see. Okay, so now onto the cosine graph. The equation is y equals cosine 2x. To graph, you have to find the amplitude and the period. We know that the amplitude is 1 because there's no coefficient in front of cosine, as you can see right here. So it's automatically 1. And in order to find the period, you just do 2 pi divided by 2, which will leave you with pi. So when you and after that, you graph the parent function, and then you divide all of them by 2, all the x values, because for the cosine graph, all of the x values are going to equal cosine. So after that, you get a horizontal shrink because the graph got smaller, and yeah, that's how you graph a cosine and sine graph. Okay, Ms. Soohoo, well, I hope you were able to get through watching my solo video, and you were able to, tolerate my voice the whole time. But yeah, and yeah, thanks for watching my Unit 9 video.